Welcome back, guys. Let's solve today's question 1. So this question says that you have an array of non-negative integers, and for this let's define f of a comma x as a1 mod x, a2 mod x till an mod x. So each array element is replaced with a mod x, right? ai mod x for some positive integer x. Find the biggest x such that this f array is a palindrome. Here a mod x is the remainder, that is mod's definition, and a palindrome is this array should be palindrome, so first should be the same as the first from the end, and we need to find a maximum x. Will be given an array, a particular array A. We need to find the maximum value of x possible such that once we replace this array A with this modified array, then it should be a palindrome. Okay, so let's say what the question is. We'll be given an array A and we need the maximum possible x such that if all these elements ai mod x, for all the elements, for all these element ai, we do ai mod x, then this resulting array b, let's say this array b should be a palindrome. Okay, so we'll start. So we'll start from the end. Okay, we need to find this maximum possible k. This x is unknown, but we know that the final array should be a palindrome, so we'll start with that. So let's say this is the array and this is a, not a, let's say b, b1, b2, b3 up to bn. And what is b1? b1 is nothing but a1 mod x, and we don't know x now. This is some arbitrary x we are assuming. Similarly, b2 is equal to a2 mod x and bn equals to an mod x. Okay, and what is this a values? These a values are given. I'm just generalizing the question. So will be given, what will be given is all these a values, array a. We need to find the maximum x such that once we create an array b, which is a1 mod x, a2 mod x, a3 mod x, so this b should be a palindrome. That means this first element should be equal to the first element from the last. That means b1 should be equal to bn, b2 equals to bn minus 1. Got it? So likewise, so this should be a palindrome. I'll note it here. This should be a palindrome. Now what is b1 or b2 and bn? Okay, so let's say this original a, okay, I'll just use this single statement that b1 should be equal to b of n. What is b1? b1 is a1 mod x should be equal to a2 mod x. Now what is a1? a1 is some multiple of x, right, plus some integer. So it, let's say p times of x plus q. Okay, so p times of x plus q. I'll assume this as a1 and I'll assume a2 as mod, okay, as a1 mod x equals to a2 mod x, and this is the remainder. In this case q is the remainder, so in the second case also q should be the remainder, so there should be extra q, and this is the pth multiple of x. Let's say this is some rth multiple of x, it can be anything, right? So this should be a general two numbers, right? This is not a2, this is an. So as a1 mod x should be equal to a2 mod x, okay, as this condition must hold true, the remainders the remainders should be equal. As this is a palindrome, it should be equal, so the remainders is equal. And this is a general way, right, of writing this, because a1 mod x gives q and a2 an mod x. No, this is not an2, this is an. So this a2 mod x gives q also, as you can see. This is some pth multiple of x, this is some rth multiple of x plus some q plus the same q. This is the remainder. This is a general way. Now what we need to find is the maximum x, and we have a1 and an. We have a1 and an, we don't have x, so we can't find q because we don't know x. So we don't know a1 mod x because we don't know x. We want to find x, we need to print out the maximum value of x. So is there something we can do? There are lots of unknown, right? This is some pth multiple, this is some rth multiple, and we have also assumed the remainder to be q, and this x itself is unknown. There are a lot of multiples. So we need to reduce the variables down. We need to reduce it down. As you can see, this q is same, right? So as one of the variables is same in these two numbers, we can directly subtract this and remove this. So I'll do that. a1 minus an, and as a1 is this and a1 is this and an is this, once we subtract this, it becomes p minus r times of this x, and this q is vanished. We have erased this q because this q is same. Once we subtract it, this q gets cancelled, so we are remained is p times x minus r times x, which is p minus r times x. And now we know a1 minus an. Why? Because we know a1, we know an, it is already given to us, so we know this, and we need to find out the maximum x possible. Okay, now this is unknown. As you can see, if we have found this out for a1 minus an, we can also find it out for a2 minus an minus 1. Similarly, a3 minus an minus 2, and it will come out to, let's say, some let's say t minus u times of x, some f minus g times of x, right? As we did all of this, we'll do similar things for these other values, and we'll get all these other values. Now we need the maximum x. If you can notice, if we need this maximum, we can also make a comment. This is an observation that if we need a maximum x such that all this condition holds true, so let's say this difference, okay, I'll write it down. Let's say this is the difference 1, this is the difference 2, this is the difference 3. If you can notice, in every difference x is present. So we can directly make a comment that for maximum x, that means the maximum number that should be present here, such that a product of this should be some difference. This is nothing but the GCD of all the differences. For the maximum x is nothing but the GCD of all the differences. Is this statement intuitive for you all? Can you get that? It is true. It is not an derivation. The statement itself is the answer, that if x is maximum and the structure of x is such that it is x times something, x times something, x times something, and all these are some differences, and we need the maximum x, then x is nothing but the GCD present in all of this. The maximum common divisor present in all of these differences is the maximum x that we can get. This you need to you need some way to understand this intuitively. I have solved 2-3 questions of the similar pattern, so this statement is completely intuitive for me. You need to make this intuitive for you. I'll explain it in other words. Okay, let's say this is 8 and 12. Let's say I'll start simple. Okay, 2 and 4. Okay, let's say difference 1 is 2 and difference 2 is equal to 4. Now we need to find a number such that this x is maximum and this is some random number. Okay, so p and q are random numbers, and there is a constraint on x that this x should be maximum number possible, such that x times of p is equal to 2, which is difference 1, and x times of q should be 4. So the one thing you can do is, this is GCD itself, that the maximum common divisor present in D1 and D2, it is 2. So 2 times of 1 equal to 2 times of 2, x equals to 2. Okay, I hope you guys understood this using an example, that the statement that x multiplied by something, x multiplied by something, x multiplied by something, and we need to maximize this x, then this x is nothing but GCD. This maximum x is nothing but the GCD of all the individual elements. Okay, so that is the solution. I'll show you the implementation. So I got a TLE, I'll tell you why. Okay, so this is the question, that I take the input in the array, and for each elements, from a0 till an by 2, I check a0 with an minus 1, I check a0 with an minus 1. So difference of a0 and an minus 1, that means the first element and the first element from the last, the difference of these two elements, I take the GCD, and I need the GCD of all other differences. What is difference 2? Difference 2 is a1 and a of n minus 2, a3 a of n minus 2, a4 a of n minus 3. So differences of the pairs of palindrome, pair of elements of palindrome. Okay, according to the palindrome there will be pairs generated, right? The first element should be paired with the last element, the second element from the beginning should be paired with the last second element. Similarly, the differences of these pairs, the absolute value, the GCD of all these differences is Rx. So that is what I did, but what I did wrong was, I'll show you that too. When I tried, okay, I should not have, okay, I'll show you here. Okay, while taking GCD, okay, don't worry, it has opened. So the TLE and the right answer, I'll compare both of these. Okay, I can compare. Okay, yeah, so in the previous thing, what GCD I tried to, okay, this is complicated. So till this was my first approach, which got a TLE. Everything is same, just this GCD function is different. What was different is that I was doing p minus, if p is greater than equal to q, I am doing p is equal to p minus q. So I am subtracting the lesser value from the greater value. Okay, so I am taking this step by step. So that's why it was very slow, because let's say p was 1000 and q was 1. What I was doing was, I was decreasing q by 1. So it was 1001, then it became 99999 and 1, then again 9998 and 1. Okay, likewise I was doing it step by step. Instead, what we had to do was directly mod, okay, Euclidean algorithm, that p comma q has the same GCD as p mod q comma q. So this is the Euclidean algorithm, and that is why I was getting an TLE. So keep this in mind. Okay, instead of doing it step by step, directly use the mod. I hope you guys understood the solution.